Hello learners, this is Mr. Beckwith and you are watching Flashback Friday. Today we are going to look at the reason why our day and night cycle changes over the course of the year, and we're going to look at why the seasons change over the course of the year. And both of these things occur because of the tilt of the Earth's axis and the rotation upon that axis, as well as the Earth revolving and orbiting around the sun. This causes different amounts of direct sunlight depending on what time of the year it is. So let's take a look at a couple of models and see if we can get a little bit better grasp on this.
So as we have discussed before, the Earth rotates on its axis, and the axis is just an invisible line that goes through the center of the Earth. And the axis is at a tilt of 23.5 degrees. So what that means is, depending on the time of year, there are different amounts of direct sunlight. So in the summer, in the northern hemisphere, we get an increase in the amount of sunlight, and in the southern hemisphere they experience winter because they have a lower amount of direct sunlight. And then as the Earth orbits, it flip-flops. So it becomes winter in the northern hemisphere because there's less direct sunlight, and summer in the southern hemisphere because there is more direct sunlight. So as we can see in this graphic, we can see the amount of direct sunlight affecting the Earth as the months change. And so here we are in winter for us in December, and you can see the amount of direct sunlight on the Earth in the northern hemisphere versus the southern hemisphere. And that's really important because it's not only the length of day, but also the intensity of the light itself. The light in the northern hemisphere is spread out, whereas the southern, it's very concentrated. And then as we move through the seasons and we move through the year, we move towards spring for us and fall for the southern. And you can see that the amount of sunlight is even. It's evenly distributed. So that's why we have an equal day and an equal night during that part of the year. And then as we continue on into the summer months, we see that now we flip-flopped, and the amount of direct sunlight in the northern hemisphere is greater than in the southern hemisphere. Southern hemisphere, the nights are starting to get longer, and for us in the northern hemisphere, our nights are starting to get shorter and our days are longer. All of this contributes to the change in season. So again, another thing to consider, summer in the north means winter in the south, and vice versa. And then when we get to the fall, once again, we see that equal amount of direct sunlight in the northern and the southern. And this affects our temperature in our oceans, it affects weather patterns, it affects a lot of things with our climate.
So learners, I hope that the modeling that we just looked at was helpful for you. It is a little bit of a strange process to think about because it's really a fourth dimensional or 4D process, because we're not only talking about three-dimensional space, but we're talking about objects moving through that space over time. So sometimes it's a little bit hard to conceptualize, but just remember, the more direct sunlight that we have, the warmer the climate is going to be. So in summertime, when we have lots of direct sunlight, it's very, very warm. In the winter, when we have less direct sunlight, it's going to be much colder. And also remember that depending on where you are on planet Earth, if you're in the northern hemisphere, your summer is during June, July, and August. But for the southern hemisphere, their June, July, August, those are their winter months. And again, this is all due to the tilt of the Earth's axis.